Here's a good example of where, when we look at it, you may recognize this as a square root graph. But everything in this question is in function notation. It says we have the graph of y equals f of x, and sketch the graph of y equals 4, negative 0.5x. For our description this time, we're going to do it a little bit shorter. We're going to point to this 4, and instead of writing out the word vertical, is everybody okay with the letter V? Is that 4 going to be a stretch or a compression? Stretch. Next, we have a negative. Is that going to be horizontal or vertical? Does it affect the x or the y? X. So that will be a horizontal reflection. And then we have the 0.5. That's also inside, so it's going to be horizontal. Will that be a stretch or a reflection? Or stretch or reflection? Well, I kind of gave it away there. Stretch or compression. Because it's a 0.5, we would multiply by 2 over 1, so it would be a horizontal stretch. And now underneath these, we're going to write what would happen. For this vertical stretch, you would multiply the y by 4. And when you have a reflection and a stretch, or a reflection and a compression, those can be combined at the same time, because one will multiply by negative 1. The other one, in this case, multiplies by 2. Putting them both together just means you have to multiply your x values by negative 2. So what's that going to look like? Well, let's pick some key points. This is the most important point here at negative 2, 0, because that is the starting point of this graph. It looks like we have another nice point right there. Looking at what is happening to my coordinates, I'm multiplying by 4, I'm multiplying by negative 2. I really don't have to worry about fractions. Whereas the last example, when we were multiplying by a quarter, we thought about fractions and chose points that could kind of avoid them. But this time we don't have to worry about that. So I could choose negative 1, 1. And if I chose another point, 2, 2. Draw my arrows, and above my arrows, describe what you're going to do with your point. You're going to multiply your y values by 4, your x values by negative 2. And this is the easiest place to make a mistake, because the math isn't hard. So sometimes your brain will start thinking about what you have to do next, and then you'll multiply your x's and y's by the wrong numbers, or you'll see this negative 2, and it'll confuse you with another number. I don't know. Your brain does crazy things if you're not paying attention. So one thing you could do, you could say, okay, to make sure I multiply my x values by negative 2, I'm going to do all my x values first. So this one will become 4, this one will become 2, this one will become negative 4. My y values by 4, this will stay 0, this will be 4, this will be 8. So we can label our new points. 4, 0, 2, 4, and negative 4, 8, I guess would be somewhere over there. I'll label those with the coordinates as well. 4, 0, 2, 4, and negative 4, 8. Now in this graph, this was the starting point of my square root graph. That was this one right here, so that means this point right there corresponds to that one. And that's going to be important because when I go to join the dots, sometimes you might say, oh, I'm going to start here and join them. Well, in this case, it's important to know where the original starting point was. Now our graph needs to go this way. To check, the shape is basically the same. It's been stretched, it's been reflected. But if I go through the blue things that I've written, do I have a vertical stretch? Appears to be. Can I see the horizontal reflection over the y-axis? Yes, my new graph is going in the opposite direction. And then a horizontal stretch. Possibly you can see that sometimes the stretches are hard to see, especially if there's been a vertical one and a horizontal one. But that reflection is a key thing. That makes sense why my graph is going in the other direction. State the domain and range of each. I'll go back to set notation for this one. Domain of the first one, x is bigger than or equal to -2. The range, y is bigger than or equal to 0. And for the green one, I'll use interval notation just to let you see what that looks like. For your domain, interval notation, you always think about the smallest value first. Since it goes forever to the left, it would start at -infinity, and then your biggest value is 4, and 4 would have a square bracket because it's included. And for your range, your smallest y value is 0, and your largest y value goes up forever, would be infinity. Are you ready to make your brains think? Because what I'm going to do next is going to be some abstract stuff. We're done this question. But to really practice working with explicit notation and function notation, what I'm going to do next is going to require some concentration. So first of all, 7, 9, and 10 are your questions. And now we're going to see if you can think about this as an explicit equation. So starting off, we had our red graph was y equals f of x. Our green graph was y equals 4f of -0.5x. Okay? But if we look at our red graph, you should be able to recognize that that was a square root graph, and that square root graph was moved 2 to the right. So how would I write that as an explicit equation? How would I write a square root graph moved 2 to the right? I don't have my square root sign. It would be inside. Oh, so it's not 2 to the right, it's 2 to the left. Okay? To move 2 to the left, would it be +2 or -2? +2. So are you okay with that being our explicit equation for the red graph? And because we have the function notation for the green graph, what we're doing now is practicing translating function notation to explicit notation. The 4 is outside the function, so the 4 will be outside the square root. Inside the function, I now have a -0.5x. How do functions work? If this was f of x, x plus 2, and I asked you to find f of 5, you plug in 5 for x. Now I'm asking you to find f of -0.5x, so you have to plug in -0.5x wherever there was an x originally. So this equation becomes -0.5x, and then there's still the +2. that would be the explicit equation for the green graph. All right, we're going to do our last example.